Okay, people, you're welcome to Easy Maths Tutor class, live JAMB prep class. I'm happy to have you here, and we are ready to start our class. We're ready to start our class. So, in the previous class, we're supposed to solve a problem. So I'll quickly go to that problem, and let's just go right ahead without wasting extra time. Okay, so this was where we were. Question 2, where to simplify 5 plus root 7 all over 3 plus root 7. So the solution is that we are going to rationalize the denominator with its conjugate. So quickly, we'll go right ahead and do that. So we'll say 5 plus root 7 all over 3 plus root 7 times 3 minus root 7 all over 3 minus root 7. So we're going to multiply this quickly. We'll multiply 5 by 3 minus root 7 plus root 7 times 3 minus root 7 for the numerator. So let's do that quickly. 5 times 3 gives us 15. 5 times minus root 7 gives us minus 5 root 7. Root 7 times 3 gives us plus 3 plus 3 root 7. Then root 7 times minus root 7 gives us minus 7. All over. 3 times 3 gives us 9. Root 7 times minus root 7 gives us minus 7. So our value will be 7, right? Minus 5 root 7 plus 3 root 7 all over 2. 15 minus 7 gives us 8. Minus 5 plus 3, since they are both root 7, minus 5 plus 3 will give us minus 2 root 7 all over 2. So we're all going to divide the numerator by 2, each of the terms in the numerator by 2, right? So this 2 comes out here 4. This 2 cancels this out, giving us 4 minus root 7 as our final answer. So question 2, yes, we got B as the answer. We got B as the answer. Got B as the answer. Got B as the answer. All right. So we're going to quickly move on to question 3. We're going to quickly move on to question 3. Mosquitoes. We live in Africa, so we have a lot of mosquitoes. And this is what I use to deal with the mosquitoes. Oh, oof, oof. And then when it hits the mosquitoes, you hear a frying sound. Mosquito, if I get you, if I catch you, you're going to get fried. Okay? I'm going to demonstrate how you get fried. Okay? So let's continue. Okay. So let's quickly go to our question 3. Question 3. Okay. So our question 3 today is rather slow, but at least we are okay. So the question says find the remainder when x cubed minus 2x squared plus 3x minus 3 is divided by a factor x squared plus 1. The options A is 2x minus 1. Option B is x plus 3. Option C is 2x plus 1. And option D is x minus 3. So solution. This is under the topic polynomials. It's under the topic polynomials. So what do we do? To find the remainder, we have to do a long division. A long division. So you draw a division sign that looks like this. Okay, so we'll write the main function, which is x squared, x cubed, minus 2x squared plus 3x minus 3. So we are dividing it by x squared plus 1. Dividing it by x squared plus 1. So how do we go about this? How do we go about this? So, first of all, take the first term, which is x squared, and divide by the first term, which is x cubed. So we know that x cubed divided by x squared is x, because the 2x in the denominator will cancel out the 3x in the numerator, leaving us with 1x. So we will have x, right? Then we will multiply x by x times x squared gives us x cubed. X times 1 gives us x. We are going to write it on the part that has x. Okay, we can write it here because we will not be able to subtract it because they are not like terms. So we will subtract just the same way you subtract in the traditional subtraction. X cubed minus x cubed gives us 0. Minus 2x squared minus nothing, 0 gives us minus 2x squared. 3x minus x, this becomes minus because we're subtracting, gives us 2x. So now we are going to divide minus 2x by x squared. Minus 2x squared minus 2x squared will be divided by x squared. So this will cancel this, and our answer will be minus 2. So we'll write write minus 2, right? So we'll multiply minus 2 by x squared. We'll multiply minus 2 by x squared plus 1, giving us what? Minus 2x squared, right? Sorry, we'll also bring this down. Okay, so we'll have minus 2x squared minus 2x squared minus 2. Minus 2 will be written here, and then we will subtract. So this will give us 0. This will give us 2x. This becomes plus because we are subtracting. So we say minus 3 plus 2 gives us what? Minus 1. Therefore, this is our remainder. It's our remainder because we can no longer divide 2x by x squared because x is lower in the exponential than x squared. So our remainder is 2x minus 1. And our answer is A. And our option is A. So we're quickly going to do the fourth question. The fourth question says factorize completely. (16x squared). Factorize completely 9y squared minus 16x squared. So, solution. If you've not subscribed already, please remember to subscribe, like, comment, and share this video with your friends. So, when I see such a factorization problem, we'll rewrite it here, 9y squared minus 16x squared. I remember the difference of two squares, which is a squared minus b squared. And we know a squared minus b squared is the same thing as a plus b bracket a minus b. So we are going to replicate the same thing in this equation. But first of all, we must make it look like a perfect square. So we will have 3y squared. Well, first of all, before we do that, let's do like this. 3 square y squared minus 4 square x squared. Because we know that 9 is 3 square and 16 is 4 square. So we'll have 3y squared minus 4x squared. factorize completely, so we have to make it look like this equation up here. Therefore, we will have 3y plus 4x brackets 3y minus 4x, and this is our complete factorization. Okay, the option is B. Now I'm solving JAMB past question 2021. Okay, so we're solving our fifth question, right? Our fifth question. So it's a question 1, 2, 3, 4, 5. So the question says solve for x and y respectively in the simultaneous equations. But the simultaneous equations are minus 2x minus 5y equal to 3. The second one is x plus 3y equal to 0. Solve for x and y respectively in the simultaneous equation. Solution. So we're going to name the equations, equation 1 and second one equation 2. So we'll say from equation 2, we make x subject to the formula, giving us x equal to minus 3y. And then we'll substitute into equation 1. We'll say substitute x into equation 1. So we have minus 2 minus 3y minus 5y equal to 3. So minus 2 minus 3y gives us 6y minus 5y equal to 3, which is y equal to 3. So we've gotten the value of y, but for us to have the value of x, we'll substitute back into this equation where x is a subject. So we have minus 3 times y minus 3 times 3 equal to minus 9. So x is minus 9 and y is 3. Okay, x is 3, y is 3, x is minus 9. So the correct option is C. The correct option is C. So we're going to our question 1, 2, 3, 4, 5, 6. Our question 6. Our question 6. Okay, our question 6. Question 6 is a variation problem. So variation problem. 1, 2, 3, 4, 5, 6. Okay, so the question says if x varies directly, if x varies as square root of y, 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 and sorry, and x is equal to 81 when y is equal to 9. Find x when y is equal to 1 over 7, 1 whole number 7 over 9. So our options are 20 whole number 1 over 4, B, 27, C, 2 whole number 1 over 4, and D, 36. Solution. If x varies directly as square root of y and x is equal to 81, when y is 9, find I have to hold this standby, okay, to fight off the bugs. So if x varies directly as square root of y and x is equal to 81 when y is equal to 9, find x when y is equal to 1 whole number 7 over 9. So how do we do this? We are going to write out the expression variation. X varies directly as square root of y. That means x varies directly as the square root of y. Okay? So if we are to convert this to equality, we'll write it as this: x equal to k square root of y, taking k as a constant of proportionality. So we'll say x is 81 and y is 9. Therefore, making k subject to the formula, we divide both sides by the square root of 9, giving us 81 all over the square root of 9. So we know that 81 over 3. 3 goes here, 1, 3 goes here, 2, 7. So k is 27. So we'll substitute k back into this equation, giving us x is equal to 27, the square root of y. So we're asked to find x when y is one whole number. Y is one whole number 7 over 9. So we ought to convert one whole number 7 over 9 to improper fraction. So we have 9 times 1, 9, plus 7 gives us 16 over 9. So we'll substitute that back into the equation to have x equal to 27, the square root of 16 over 9. So we know this is 27 times the square root of 16 all over the square root of 9. Right? We know, remember the law, there's this law in mathematics that states if you have the square root of a over b, it's the same thing as the square root of a all over the square root of b. But if you have the square root of a times b is equal to the square root of a times the square root of b. So we are going to apply that law, this law in this case. So we'll have 27 times the square root of 16 is 4, and the square root of 9 is 3. 3 cancels here once, 3 cancels here 9 times. Therefore, 9 times 4 is 36. And there we have it. The correct option is D. And now we're going to solve our final problem. Our final problem before we call it a day. Our final problem before we call it a day, that is question 7. Sorry, question 7. We say T varies as the cube of R is equal to 3. And T is equal to 2 over 81. Find T when R is equal to 2. Our options: A is 1 over 18. Option B is 1 over 12. Option C, 1 over 24. And option D, 1 over 6. Okay, so solution. So we're going to write out we are going to write out the expression, right? You see, T varies inversely as the cube of R. Inversely means it's 1 over whatever it varies with. So we're going to substitute R equal to 3 and T equal to 2 over. So we say 2 over 81. So converting this to equality, we have 2 over 81 K all over 3 Q. So making K subject of the formula means we're going to move 3 raised to power 3 to the numerator of the other side. Since it's at the denominator, so we will have 2 times 3 raised to power 3 all over 81. Or we'll multiply both sides by 3 raised to power 3. So what do we have? K is equal to 2 times 3 raised to power 3, and we know that 81 is 3 raised to power 4. So this will cancel this, right? Give us K equal to 2 over 3. So substituting this back into this equation, we will have T. Remember, T is inversely proportional to the cube root of R. So T is equal to K over R cube. Therefore, T is equal to 2 over 3 1 over r row cube, which is the same thing as c equal to 2 over 3 r row cube. So the real question says we should find the value of t when r is 2. The value of t when r is 2. So we say t is equal to 2 over 3 times 2 raised to the power 3. 2 cancels here, 2 cancels is 2. Remaining 2, giving us 1 all over 3 times 2 raised to the power 2, which is 1 all over 3 times 4. Therefore, t is equal to 1 over 12, which is B. And there we have it. We have come to the end of this wonderful session. So I'll see you in our next class. I don't know when next, but whenever we have time, we're going to have another live class. God bless you. Do not forget to subscribe, like, and share. And then you can also support this channel in any way possible. Thank you. See you in our next class. Bye. Good night. Sleep tight.